Okay, what we're going to do is talk a little bit about what's expected of you in the lab tomorrow. The lab that we are doing is called calorimetry, and calorimetry basically means the measurement of heat transfer. So in calorimetry, what we're going to do is measure the heat transferred from a hotter object to a cooler object. And in this lab, what you're going to do is you're going to heat up a piece of metal that's going to look like a cylinder, and what you're going to do is drop it into a styrofoam cup that contains water. And what we're going to be able to do is measure how much heat is transferred from the metal into the water. This process is referred to as constant pressure calorimetry. The idea being that if you're using a coffee cup as the measuring device, in other words what we call a calorimeter, air pressure pushing down on the liquid is going to be at constant pressure. There's different types of calorimetry, but we're not going to get into the definitions of those. Constant pressure calorimetry is often referred to as coffee cup calorimetry for obvious reasons. So the measuring device that we're going to use is a coffee cup. So anyway, this is a diagram of what a coffee cup calorimeter looks like, and we're going to use the same basic setup tomorrow in class. So our coffee cups won't have a lid on them, so we'll get rid of that, and we won't have a stirrer either, but we will use a thermometer. So what you're going to do is you're going to have a hot plate, and on that hot plate you're going to have a beaker of water. And you're going to get that water boiling, so it's going to boil at 100 degrees Celsius. And then what you're going to do is you're going to take your 3 metal cylinders and you're going to put it in that boiling water, and you're going to leave it there for about 10 minutes. The idea is when we take that metal cylinder out of the boiling water and put it into our coffee cup calorimeter, the metal should be at 100 degrees Celsius. So our metal will have an initial temperature of 100 degrees Celsius. The initial temperature of our water should be approximately 25 degrees Celsius. So then what's going to happen when you put that metal into the room temperature water, the water in the coffee cup calorimeter is going to increase, the temperature of the metal is going to decrease until they equal approximately the same temperature. And that might come out to be somewhere around 30 degrees Celsius. So the metal is going to cool down, the water is going to warm up until we have the same temperature. The idea behind this is that if we know how much heat is transferred out of the metal, so remember Q is the value that we use for heat, that same amount of heat is going to be transferred into the water. So what we're going to do as the metal cools down and the water heats up, we want to know how much heat we're losing from the metal. So we're going to calculate Q is equal to MC delta T for the metal, and the amount of heat that's transferred into the water we can calculate by going delta, or Q is equal to MC delta T for the water. So since the amount of heat transferred out of the metal is equal to the amount of heat transferred into the water, what we can do is set these equations equal to one another. So what we want to do is set the amount of heat, which is Q, which is also MC delta T for the metal, equal to the amount of heat, or MC delta T for the water. So that's going to be the mass of the water in the styrofoam cup. That's going to be your C value for water, which you know is 4.18, and the units are joules per gram degrees Celsius. And our temperature change here, TF minus TI, we're going to know what TI is, and we're going to know what TF is once the temperature stops rising. Over here, this is going to be the mass of our metal. This, the specific heat of the metal, is what we're trying to calculate. We're going to know the initial temperature of our metal because that's going to be the 100 degrees Celsius. And the final temperature is going to be the same final temperature as our water. So what we're trying to solve for in this equation is the specific heat of the metal. Now, since the heat is leaving the metal, that's going to be exothermic. So we're going to set this whole side equal to a negative value. This whole side is going to stay positive because the heat is being transferred into the metal. So if we solve for our equation, it's going to be negative mass of the metal, specific heat of the metal, Tf minus Ti for the metal, and we'll set that equal to the mass of the water, specific heat of the water, Tf minus Ti for the water. And we're going to solve for delta, or we're going to solve for specific heat. Alright, so what you're going to do when you get here for the lab, you're going to gather all your lab materials, and it'll be pretty straightforward. You're going to set up the lab apparatus, and you saw the diagram on the earlier slide. You're going to work with all three metals at the same time. So you're going to get your water boiling, and you're going to put all three metals in the boiling water. And you can actually measure two at a time if you have two separate coffee cup calorimeters, because the GLXs have two ports. You're going to complete the calculations on the back of the lab sheet that you already have. And then I'm going to give you follow-up questions tomorrow while you're doing the lab, and you're going to complete those 2 days after the lab. So since tomorrow is Tuesday, those will be due on Thursday. Email if you have any questions to thannanen@ldsd.org, and I will see you in the lab tomorrow.